Hope you had a great weekend. Today's opening question of the day is, what do we need in order to see light? Take a few minutes, 5 minutes, you can talk to your peers. Please discuss, and we'll talk about it soon.
So did you go to that concert last night?
Yeah, it was so fun.
But did you see his hair? It was green.
I know. I wonder why it was like that.
We're learning about light. I don't know what concert you went to. I hope it is great, but we're talking about light today.
But we're talking about the light at the concert. His hair was green because of all the lights. And
Really?
I don't get it.
That's actually an interesting point. I'm actually going to use you as an example. Thank you. Did everyone hear what you said? You want to repeat that, what you said to the class? About his hair?
His hair is green from the light. But I don't get why.
Well, today we are going to learn why his hair was green. Well, actually, I can tell you guys exactly what's going on. It was all in the lights. But first, let's look at the basics. In order to see an object, you need two things. First, a light source, and second, a clear, uninterrupted path for light to travel from an object to your eye.
Professor Marski, I think I can add to that.
Please do.
It's also important to note that our eyes can only see 3 colors because of the cones and rods that we have. Every color is true to one of those, or is a combination of the 3. These 3 primary colors consist of red, green, and blue, based on the rods and cones in our eyes.
That's really good. Did everyone hear that? And light is part of the additive color, so mixing them all together produces what we know as white light. This can be seen in the diagram provided.
Now that we've gone over the basics, we can look at your concert experience.
In this picture, the artist's hair, skin, and shirt appeared green. This is due to the reflection of green light that came from a white light passing through a screen behind the performer. The light was green after passing through a green screen that blocked the red and blue rays of light, thus only allowing green light to continue. So, as you can see in the following example, when the white light passed through a green screen, only the green light continued on.
So, once the green light made it through the screen, there is only green light left. But the surface that this light is reflecting off can still impact the color. In the case of your singer, his white shirt would reflect all of the green light, but his skin and hair would absorb some while reflecting the rest. This is why the colors show slight variation.
That kind of reminds me of the fireworks I saw the other night, but they were much more colorful. I can show you a picture.
Okay, great. Well, we can look at this picture in 2 ways. One is being more simple. As we mentioned from the first example, the color of the surface that a light reflects off of can impact the color because different colors will reflect or absorb other colors, depending on their color.
Right. However, in this picture, we only have one consistent surface. However, this picture is also more complex than the concert picture because it includes more colors. In the first picture, the primary light focus was green light. In the case of the fireworks, we can see white light, which is a combination of the three colors blue and red, blue, red, and green.
Wow, I just thought these were cool pictures. I had no idea about all this light stuff.
Right? There's so much more than meets the eye.
That concludes our light lesson for the day. So let's try it again. 1, 2, 3. That concludes our light lesson for the day.